Hello, everybody. Welcome back to week 2 of class. Module 2 starts tonight. Technically, modules and weeks don't have to line up, but in most of your classes, they do. I think everybody in this class is getting close to graduating, so you may have seen one where it doesn't. Usually, it's module 1 has the introduction stuff, and they expect it to take you about 20 minutes. So then you jump into module 2, and there's tons of stuff. But they don't have to be one-to-one. They usually are. This one is. So everything labeled as a module corresponds nicely to our weeks. So we kind of looked at things in preview mode. Filters were a little bit out of place. You might have noticed it seemed like kind of an advanced feature, but I wanted to do something interesting the first week. And those don't explicitly fit in another category. They are kind of a thing. A very useful thing, scripts. It's just write whatever script you want to use. It's designed for bash scripts, but it'll use Python scripts or anything that will run as an interpreted language. In the modern world, that's pretty much Python is what we use. Soon maybe replaced by Mojo when that gets released this summer. Before we look at that, so tonight we're going to kind of jump into the material, not in preview mode, actually looking at stuff, looking at commits and some stuff about logs. And I guess we'll see using it as a version control tool. Actually using it as version control. So I have some notes so I don't get carried away. This is the classroom. I think a couple of y'all have Python in that latest course development shell and seen that Django tutorial where they tried to shove everything about Django into that, and somebody chose that for an 8-week course, and it's a bit overwhelming. It's a lot to shove in there. You just need an introduction in the class, right? You just need a really good foundation, and those other things we can build the finer details on later. So I was setting it up that way, so I jotted down some notes so I don't get too carried away. Like when we get to pretty print on the logs here, probably after a break. But first off, one of the biggest things about source code management, so Git SCM, source code management software, and we're using it as version control. There's a subtle difference in that source code is obviously for programming explicitly, and version control could be for anything. I think in the discussion board, somebody mentioned version control in the publishing industry. Very, very common there for editorials and writing things. So you can also do that. Git would work for all of your written documents and stuff as well, photographs, animation, anything on computers, but it is kind of designed to be for source code. So we need a way to keep track of the different versions, every change that we make. And the formal term is, or not the changes we make, because obviously we're going to go back and forth, make different decisions. But once we think we're happy with something, we want to commit to that change. So that's the first thing to look at here, is look at committing things. And I'm just going to jump in and do it by example. So I'm going to be using PowerShell, but Git instructions are the same everywhere. The only thing that will be different is in covering a PowerShell command. Like PowerShell has a really nice new item creation thing. It would, whatever your system does to create a new file would work just kind of the same way. CD is the same in all of them, but it means different things. Like on PowerShell here, CD is like a carryover from command prompt, but CD is current directory. It's a variable here. So we just change what's in that variable and it automatically changes our current working directory. Where it is in a bash shell, CD is actually a function to change to a different directory. So slight differences like that, but if I do anything in the example in PowerShell and you're not sure what I'm doing, or it doesn't work on your system, please don't hesitate to ask. I'll clear up any instructions. Or yeah, if you're following along the example and something doesn't work, definitely ask immediately, and we'll clear up any issues, because some of them might be PowerShell commands I forgot to mention. If you're following along on a bash script and it doesn't behave the same, those slight differences. So I'm going to make a new directory, which I'm not even going to use PowerShell, because I'm going to use one that works everywhere. Make all of our programming languages have that as well. That's become the standard way to I'll call it get stuff this week. So get dash stuff. Just some name for a folder and then navigate into it. So this is the one we want to turn into our repository. We saw that before. So git initialize and then dot for the current directory. So if I list those out, I have to do this, don't I? Git child item. This is a PowerShell specific one. Let's go college for it. I can't remember the code that the word I need. It's really odd in PowerShell to list them out. And most of our formulas it's -a. So there we got a little Git folder. You can see all of that stuff. And look it up here.
I just wanted to ask because I use the dir dir space /s command to view the /. I thought it was that.
That's it. It might be my configuration. Let me see if I can look up the word for it. Git help or git.
But just because it asked it for one of the assignments, so I wanted to be sure that I should use the right command.
Attributes. That's the word I kind of think of. So in PowerShell, git child item, and for attributes, show hidden. And most of our, if you're writing command prompt, maybe it's attribute.
Attribute.
I'll just look that up.
Is it dash hidden or capital hidden?
It shouldn't be case sensitive. Let's clear that. Git. Oh.
It was a misspell.
Misspelled it. I do that sometimes. I should pay closer attention, trying to talk and type at the same time.
There's a row guy.
Attributes. Thank you. Hidden.
Hidden like that.
So I'm trying to move it up as much as I can in the terminal. We'll get to some GUIs soon. Actually, we're going to spend at the end. We're going to evaluate different GUIs and stuff. So I'm going to try to stick it with the terminal as much as can, because it really is. That's where it's
faster when you're doing remote ends and things like that.
Yes, and typically the repository is not on the computer we're actually working on. So we will get to remote stuff next week, and then the week after that we get to GitHub, most popular one. But tonight we're going to start doing some things here and make it look. So it's set up as a repository now. We just need to add some files. And I'm going to do them using my regular text editor. So I'm just going to enter the text editor name and then a file name, and that will automatically create it. So like a README file, and what is this? Mod2 example, Mod2 class 1 example. I'm probably just going to delete this, and then a broad line and a class example to look at commits and the differences between reverting and resetting. So that's what we're doing this evening. Hopefully those two words can indicate that version control thing. Revert to an earlier version versus reset to an earlier version, because they're very different operations. So I'll save that and close that. That was the text editor. So now we have a file here, and really what I want is several commits. So I'm gonna make 3 files, and I'm gonna do 1 commit for each one. I believe it's in like chapter 1 or 2 in the textbook where he mentions that's kind of bad form. Commits should always solve an issue. So you don't want to use it. A repository is your version control. It's not your backup system. Really, you should have your repository backed up, but GitHub is one of the most redundant systems on earth. So it does make a great backup system on its own once we get to GitHub. So commits should be for a purpose, like when you get to that next big step, not for every file along the way. It's not just for saving. But tonight I'm going to do that because it needs several commits to work with and don't get all kinds of files. So we saw before our command, we have the Git libraries, the commit function, and we can add a short message. But really, all this will give us is the title of the commit, the human readable title. We can do better. So instead of that, I'm just going to type git commit. But forgot to do something. Again, those really, really nice error messages. There's something to commit, but there aren't any tracked files. Nothing's happened yet. We haven't actually told our repository to pay attention to that file we're looking at. That's kind of what was going on last week with filters. Right? Remember, nothing happened, and then once we did that git add, and we call it staging the file, we actually started tracking it. We put it on the stage, so like we're a stage reference, right? Where it's being watched, it's being observed by an audience. Once it's on that stage, that filter we applied kept running over and over and over. So we have to stage our stuff, and that's the add. There's only one in here right now. Usually I use the dot because that automatically includes recursive. So it will go into any subdirectories and grab everything. But we can also explicitly state what files we want to add. We don't have to track every file in our thing. Actually, that might be an assignment this week to do an ignore, so that you can put something in there that's not going to be tracked and never will be tracked. So we'll add that. And now if I do git commit, it pops up in the text editor. Anybody look around and see the config file that said what text editor to use? Where we're looking through a bunch of different config files and all those automatically generated files last week. One of those is very clear that it says text editor vim. If you just change that to say text editor code, it opened with VS Code at this point. Or I like Sublime, so text editor Sublime. Text editor Notepad++, whatever your favorite text editor is. Lots of options out there. Git was made by the people that make Linux kernel, Linus Torvalds and his team. So it was designed for, they did it all in bash shells and used the default. The default text editor for bash shell is what the defaults do. Defaults are always set to what it would be for the default in a bash shell. So here we have 3 sections really. We have our title. The first, whoops, hit I to enter in, go into insert mode, so I'm Vim. First commit with a README, and we can get up to 72 characters there. So some messages within those 72 characters. And when we do the -m parameter and do that, that's the only part we get. Usually we want more than that. If we're tracking all our versions, we want all those details, right? So some long paragraph, added a README about the project. That, what's that?
Should it be present tense?
Oh, yes. First commit with a README. Good catch. The convention is to use it in present tense because when we come back and look at it 6 months from now, we're looking at it as if it is a current version. Add a README with the project that describes what we're going to do in the commits, and I'm just kind of rambling on here for an example. The commits tonight in class as we look at and resets, and maybe later look at pretty print on our logs. That's definitely more than 72 characters. I just rambled on for a moment to see it's clearly there. And then at the bottom, footers are used by issue trackers. So we won't use, when we get to GitHub, we'll use this a lot. Like our commits, we can say open issue number 19, and it will create a new issue for us. We can say resolve issue number 3, and it will close the issue. So other software does read through that, and information for the issue trackers are entered in the footers. We'll see all that stuff, and when you're ready, whatever text editor you're using, just save it. So I'm in Vim, so escape, then a colon and W to write, and a Q to quit, and we can do multiple commands at once. All of the commands are like one instruction long. So then we got some information. First commit with a README, 1 file change, 3 insertions. We can see a little more information if we pull up log. So here's the name, what the computer calls it. It is a hash built off of the file we just committed. So that should be unique every time. It's built off with the file with focus on these change parts, so that the only way we would come up with an identical hash is if we made the exact same file at the exact same time of day, which isn't going to happen without time machine.
Right.
But that's a couple digits way over here. But the exact same file, roughly the same time of day, and did the exact same changes in the same order. That's the only way we're going to get a hash even close to that. So that's the unique name for it. Head, it is a linked list. Has everybody seen linked list before in the programming class? Perhaps constructed your own somewhere along the way. List is a collection of pointers. It's almost a very disorganized structure in RAM, but great for humans to work with, easy to deal with. Head is always the front of the list. So the first element in our list, index 0, the way we would normally ask for it in code, is currently pointing at the main branch. As this commit on it, have the author, the date. It's hard to read that date. Before long, we'll see how to make that say 5 minutes ago, or whatever time it is. Much easier there. And then there's our full commit message. So we get that full description right there. We'll get to logs in a second, because there's more stuff we can do. We need to add some more stuff. We need several commits, so that log looks more interesting. I'm going to make a text file, and I'm just going to do random text files to have something here. First text.txt, that sounds like a good name. This is the first actual file added after the README. Save that, close that. I just hit Control S and Control W a bunch of times to close that. That's how you close windows and keyboard, since y'all can't see which keys I'm pressing. So now we can commit that next file. So once again, git add that file, git commit. Oh yeah, I'm gonna run in the text editor. So another commit. This one added the text file added a random text file to our repository. No issues to track. And I'm going to start putting that in all the footers, like no issues to track or something about the issues until we get there. Save those changes. And when we save those changes and close the file, it automatically makes the commit. Or close the text editor, it automatically makes the commit. One more file. So I'll make another file. I'll call it another. Actually, I shouldn't call it another. More.txt. So I just called that commit. I gave that commit the title another. So I probably shouldn't go reusing names. Here's another file to get rid of when we revert and reset changes. Version control system. So as you can see, I'm not putting a whole lot of thought into what's in the text file. The text file is just to have a file there, which is kind of what the project is for. Right? So I was like, pick your own project. Those course projects aren't being graded, though you all did come up with some great projects. Everybody's project sounds like something really, really useful, a good thing to have around. But it's kind of like this text file. As far as this course is concerned, it's just something to apply the Git source code management software. Then I can hit Control S, Control W, get right here. What happened?
I gotta catch up behind at least a text file.
So I just added a second text file. It's just a random text file. You can print hello world in every text file. You can probably have a blank text file in this. Oh, actually, you do want to put something in there. These numbers here, one file change, one line inserted. Yeah. Those are going to be important this evening. So you do want to put something in there. But randomness is fine for this evening. So we'll add that and make it, then commit that. Git commit. And this is a third commit. Now we have enough to start practicing some version control on this repository. No issues yet. So as far as what's going in the files, it's just randomness, but not the same randomness everywhere. Enough that we can tell each one apart. And notice it already told us what the changes were. The pound sign, number sign, hashtag, whatever you want to call that symbol, that is the comment symbol in Bash. Actually, most interpreted languages use that as the comment symbol. So that's our, those commented outlines tell what it is. And hopefully the fact that there's comments in there are a clear indication that this file is going to do something. And it's not commented out like ignore this. Those have had me in class before, maybe not the online classes, because I can only make so many changes in the online classes. But in the classroom, I'm probably seen that I never use comments unless those comments are generated in a web page. So comment is just the computer text that the computer is going to ignore, like the Python interpreter ignores Python comments. But there's absolutely nothing that stops us from ignoring, continuing that example, from ignoring Python code and only looking at the comments instead. And that's where like documentation generators come up and stuff. Maybe I'll work that into a class example simply somewhere. They're useful things to see. And then we generate entire websites from a few comments and don't have to sit there and spend forever typing that. So it's the same thing here. One built-in process is going to use this part of the file and ignore the comments. And another built-in process is going to ignore this part of the file and only read the comments. So we can do comments really allow us to do two things in text files. I don't ever use them as like comments like you may have seen other instructors do. And then as always, when we save and close that, it runs the commit. So just random stuff in files, just enough that we have stuff, 3 files, put on 3 commits. So now hopefully our log is a little more interesting. So if we say git log, with nothing else, we get that most recent commit at the top. We see the time, the 3rd commit, what was going on with it. And eventually running down there, ran out of space. This is going through Vim. So to get out of this, we still hit Q. It is still Q to quit whenever it gets there. If you haven't seen that before in a bash shell.
Space bar, you use it still to do the space down if it, or next page.
Oh, yes, git log.
You're,
Space is page down. And when you get to end, this one always confuses me, but known it for years. But I see that end highlighted and I want to hit enter. But we still have to hit Q to quit. It's one of those things that I just finally accepted. I'm never going to remember that. When I see the word end highlighted, I'm like, okay, enter should run whatever's highlighted, but it doesn't. Okay, so took up several pages. So one option we're going to want to use a lot is we add in the one line parameter. One line came together as one word, and almost all of our get parameters have 2 dashes on it. That makes it look a whole lot cleaner. Gives us the first 7 digits of the hash code, which until our projects get absolutely massive, huge things like the size the Linux kernel has grown to, 7 digits is probably going to cover a lot. Because it's built all that hash code is a hash of the current files you just committed, and special focus paid to the changes in those files. So if you keep editing the same file, some of them might be close because it's the same file, but those changes weigh into that hashing, and the timestamp also weighs into that hashing. So we know it's always going to be unique, and 7 hexadecimal digits is a lot. Right? That's that rightmost. If we're only looking at 7 of them, that leftmost column is along this last one. 4 times 16 to the 6th power. That's a pretty big number. So the likelihood of duplicates is not going to happen there. Duplicates over here are going to happen all the time. And not just in different repositories, we're going to often, things are going to make sense to give it the same name. If something went wrong and we fix it, it's probably going to make sense to do the to give it the same name when we apply that fix, or at least say fix and then that same name. So they'll blend together after a while. But git log one line, and if I'm remembering correctly, it took me a long time to get used to not typing online. It is one line. There's an E in there. It took a lot of projects before I finally didn't type online every other time. So one line, that gives us enough information to work with it. Maybe we don't want to know about the whole thing. It's like, okay, we don't need to know about that last one.
Especially when pages and pages long of notes.
Yes. Let me go back to the long version. Clear. Git log. We only had 3 commits and we've already filled up the screen. So it's getting pretty long. It's like, this is too much. I don't see the one I'm looking for. So I'm quit out of there. Git log. So a good thing to look for first is an abbreviated version of the commit. So git log one line. Whoops. One line. So we can see those names. Names, not the titles. The titles will work in some places, but not always. And if you have any duplicated titles, perfectly okay. It will definitely make places where they do work. So you always want to grab the name, the hashing. So it's too much to look at the whole thing. So let's go back one. So I'm going to copy the name from that second one, 2603 FF5, and I'm going to git log 2603 FF5. So get the log from that second commit back. And you can see we don't get as much information. We don't have, it no longer tells us anything about the head because we can't even see it when we go back a couple of bits. The head is the start of our linked list. We're over in the middle of the linked list. We don't look backwards. So if we're at index 2 on our linked list, we can't see index 0. But we can start there and go to the rest of the list and have that a shorter list. So like now it all fits on one screen. That's the first part of version control up till then. So git log is up to now. So if you want to put that in notes somewhere, I'll write it on the board. That's one of the ones so git log. Guess I could stop screen share so that it's nice and big on people's computers. Git log is up to now. Git log and then add in the commit. I'm going to write hash because we're early in the class. So if I remember, the hash is generally referred to as the name. And that message that we put on there is the title. But this early in the class, our name, you might think about that. It would work in this case. That doesn't always work. So we always want to use the hash. I'm going to write that for now, and I'll switch to the thing. And that is up to then. Anything I write on the board, those are the ones you definitely want to commit to memory. Not everything that I have down here is going to be on the board, and not everything we look at in class is in the book. The book doesn't give the full picture, and there's some really neat features that we're missing. The book doesn't tell us how to customize those logs. I just pulled it out. That's what we're going to do after a break, after we finish looking at first 2 pages of my notes here. So, git log one line. We'll go back up to the now. Almost typed online again, so maybe I'm not used to it. It's like, okay, that most recent commit didn't need to happen. That we probably didn't necessarily need that. I'll go back and commit. So git revert, and then the name of the commit we want to undo. And pay very close attention on the given assignment this week, module 2 given assignment. When you go through that and make a video, take a few moments to look at every file there. The files are named in order, like it's first, second, third, fourth, fifth. Take note of which one you're supposed to revert, and then which file, and then what actually gets changed when you revert that. So it was like this example, 1 file per commit, so you can tell which came with which one. So let's just do git revert, and then that last one on the list. So we want to change this commit. And that will pull up the text editor again. So it's like a commit message, automated, and you can see the message they put in there. They gave it a title automatically, and then they gave us a nice little body there and didn't put anything in the footer. So when we get to issue trackers, sometimes reverts are going to fix issues, right? I have a feeling everybody in here has seen that somewhere in the code, right? Your program works, and then you're sitting there thinking, oh, I have an idea. I'll do this, and then it doesn't work anymore. Oh, yeah. Revert that last commit, get back to where you just were. Undo those changes. So in a full-on team oriented workflow where everybody's working together, you would probably mark that as an issue, flag that, assign it to somebody, and then whoever fixes it, you want to make sure and resolve it, and you put it, so you put resolve number 8, and it would go closed issue number 8 on your issue tracker. That goes right in the book. In general, though, this is a good one to keep with the defaults when you do reverts. Probably stick with the thing. And I don't know why, it might just be my terminal, but since the last reset on my computer, every time I go in here, when it's the revert commit, the fully automated commit messages, it puts me someplace weird. So I have to go into insert mode and then escape back out before it'll let me hit Q to quit. I don't know why. As soon as I did a factory reset, I went into the registry and made a bunch of changes. So there's a pretty good chance I broke something.
So after, if you do a revert, standard would still be like, after the revert commit, why you did the reversion and.
Yes, you can add to that because it opens the text editor. So it's like, this is the minimum part you want there. So you don't want to delete that, but there's a pretty good chance you would want to add stuff to it. And just like when we make and it's a commit log. So just like when we make our commit, when we save and close that, we get this message, revert if our commit looks just like our thing. One file was changed, one deleted, and then we deleted the file. We deleted one line, so we erased everything in the file, and then we deleted the file itself. So now we can-
When I go back, I can like see, instead of deleting a file, I created 2 in the second commit and then change it from a dead file to a text file.
Okay,
And so you can see the changes that way.
and this is the most important part of what we're going to see before the break tonight. So notice we still have the third commit. It's still there. We just took away everything that we did when we made that commit. That's one of that's half of the most important thing we're going to see before the break. You want to remember these things. Definitely things to remember. So now, if I list things out, I'll go with LS, just to list out the files. I'm not going to worry about the hidden ones. How many files should be here? Because we did 3 files, 1 on each commit, and then we undid that third commit. So we just have those 2 files. If I come over to the File Explorer, that third file is gone. Completely gone. Well, not completely gone.
Could you control that table?
Yes, because now I could revert that. So I'll copy the name on that. Git revert that reverting that revert. That all looks good. And I have a feeling it's something I broke in my computer. Because when I hit colon, it takes me to a completely different command prompt. Cute. It takes me to a macro thing that I had no idea was in them until I accidentally went there the other day. It's like, oh no, I broke something in the registry. That might be, I might have to do a factory reset before the end of the semester. Sometimes it's dangerous to know, oh, we're still recording things. Insert mode, escape out of that, it's still recording, colon Q. Yeah, I'll quit out of there. I'm not sure what it's doing. I somehow messed something up in the registry. Maybe I should have gone to Git bash because it was adjusted after I did all those changes. But 1 file change, 1 insertion, and this time it created that file. So the file was never really deleted. We just weren't looking at it. So a linked list. Not everybody has had me in programming classes. So a common diagram to use to go over what's happening inside the computer. It's called stack heap diagram. So a stack, computers naturally operate by a stack. In particular, this stack is our code. When we write a program file, the computer reads it in backwards from what we write and stacks it up. So the last instruction we write goes in the stack first. Then the first instruction we write goes in the stack last. So everybody's seen stacks, last in, first out structure. Think of a stack of plates. The last dish you wash and put in the cabinet is the first dish you grab when it's time for the next meal. So our code goes in that way. So this is our code. A heap is, I'm just going to write RAM. A heap is the quickest, the most efficient memory structure. If you haven't seen that, it's a special type of tree. We have to add data. It's actually, if we don't have a perfect heap, we add random data to make it fit. So a very special structure, but it has a big O of 1, which means that we don't gain, we never lose efficiency, no matter how big our data set gets. It's the best one, so it's a lot of work, but most of our RAM retrieval happens there. So what a linked list is every time we have an element, we just add a pointer to the next one, which if you haven't seen that in a class, that really, in your object, you just have a data field that says next and assign it to the next one. And then that's going to point to the next element in the list. So I guess I need 3. Then this will point to, that's starting to look a little bit too organized. So this will point down to the, maybe there was some space down here in RAM. So kind of what we did is when we reverted, we just stopped pointing at this one. I'll do it in the picture here. So we just erased that pointer and had this pointer point down here. It still exists in RAM. We didn't do anything with it. We just don't have any way to get to it. But if we go back in and manually say, point to that element again, we can see it again. So it hasn't gone away. That's the important thing. It's a linked list and we did not delete it from memory when we reverted it. Oh, I meant to look at something. I should have looked at the notes that I have sitting right in front of me, because there was something else I wanted to do there. Let me revert that again.
So revert again.
Yes. Log 1 line. So version control stuff. So git revert that. So now we should be back to the 2. Okay, at least it stopped recording whatever it was doing. I didn't know Vim could record macros, but I no longer see a message that says recording. So now we should be back to 2 files. Whoops. So we have the 2 files. What really is our difference? So that's another really important one. So git diff. And then we need 2 things that we want to take the difference between. So actually, I guess I need to do the log 1 line again, so we can grab the hashes of the things we want the difference between. Git diff the current spot and way back here before we reverted and then reverted the reverted and reverted the reverted. I meant to do this a couple of months ago. But what's the difference between our current version and the very second version we had?
Is it not the 3rd commit? The 3rd?
Yes.
Because it's like another commit, a 3rd commit, and you reverted the 3rd commit.
So this has the README. So that's our first file. our second file, then the third file. And, oh, I do need that button. I just gotta move it out of the way. Okay, so then we got rid of 3. I should put a minus. We subtracted 3. We added the third file back. And now we subtracted the third file, so we should be back to this one. There's no difference between those two things.
Okay.
Make sense? Yeah.
Yeah.
Yeah, sorry, those extra reverts were a little bit of a problem, but notice that we can keep reverting back and forth. And on that picture, what we're doing is just changing the pointer in our list. We went index 0, 1, 2, and basically, well, from the picture, so it'd be in the middle. Then we went index 0, 2, and just quit pointing at 1, so there was no way to get to it. Then we brought it back in because we didn't actually delete it from RAM or anything. But we check a different difference. So what's the difference between this one, the place we're at, and the very last one? The second one down. I should pause for a second so y'all can look at those numbers because you're gonna have a different hash on the name, right?
So you're saying you're looking at the second one down, which should also be, because it was a revert of a, should also be the same.
Yes. So difference between this one and this one. That's supposed to look like an eyeball. Let me try that again. So the second one down.
Oh, second one down.
That makes sense. Oh, I guess that almost looks like 2 eyes now. This is the one we're looking at. So notice I used the check mark in the eyeball. So the one we put first compared to this one. So if there's extra files, they're going to be pluses. And if it's missing files, they're going to be minuses. So it's important to keep track of which ones, where the plus, where the minus falls. So it's in terms of the one you put first here. Actually, that might be a good thing to see both of them. So here on my screen, 80 is the top and E0 is the second one down. So 80 to E0 says there's a new file involved. Something was subtracted in the background and a file that had the plus more. But if I scroll up to that command and move this one, so copy that and then put it first. So all I did was switch the order of them. Notice now it says that it's missing a file. It's also green and red. We added these lines to a file. And then if we look at it the other way, we're missing this line from the file. So we have that information. Have a default view of the different information and stuff in those. So diff is a very important one. What is that? Same thing with third.
Diff will also show the changes within the same file. So like if you had a file, you wrote a new line in the file, it would show you the file with 1 line, 2 lines.
Yes. Get diff. In any 2 parameters that it will accept, so we're just starting out, the only one we've seen so far is using the name of a commit. But a file name is a parameter. Another repository that we cloned is a parameter. A branch on our repository is a parameter, because I assume everybody's heard the name of the word branches before, even though we haven't talked about it in class. We'll talk about soon. But anything that we can talk about, it will give us the difference between those. Just put it at the 2 things you want to compare it to. Or add another parameter. In that case, like what he was asking about, you would do that get different between second commit, get third commit, and then add a file name in so it only looks at that file name. You're gonna want to play around with these things, but that's another one of the critical ones. You're definitely going to want to commit to memory. So let me erase this picture. Also wanted to introduce that picture for those who haven't had me in a face-to-face class. I'll take time and we'll draw lots of diagrams, explain about what's going on in the inside, and stack heap diagrams are one of the most common ones we'll see. Git, diff, and then I'm using angle brackets for fill the unique thing, the stuff to fill in. FMIs, you've probably seen that in instructions. The fill me ins, almost always done with angle brackets. So again, it's going to be the commit hash. I'll put commit to hash, the two work because we need to compare two different versions. Other parameters. We can extend that. We will see that extended soon. But since there was a question about it, so we could restrict that to just one particular file. But in our case, we each commit only had a single file.
Is there a maximum parameters that you can use for diff?
For this part,
Yeah. Okay.
well, when you run out of RAM. So technically, yes, but in 2023, more than you would type in a lifetime.
Okay.
So we shall have revert things and then undo those reverts, revert the reverts, revert the reverts. What if we know we're not going to revert the reverts and we're not going to do all that stuff? So git log one line. So we are back to a 2-version system. So along with the revert, we also have a reset. And it would kind of follow the same way. Oh, I didn't put revert on the board. Revert is definitely one that should have gone on the board. I'll put that on the board in a moment. We would probably run git diff before we actually revert and reset. Look at those differences and then revert to the earlier version if that's the one we want. Kind of the same thing. Let's reset this most recent revert. So I'm going to copy the one on top, paste that in there, and then I'm going to add a parameter of hard. Oh, I guess I could have left that picture up there.
Which one did you go to?
So the one on top, 80, yeah. I can remind them. I'll try to describe it that way. Maybe we should use the titles. The one will revert. I reverted the third commit. I guess that is similar, but your titles might be a little bit different. So when we do this, which I erased the picture, I'll put a quick picture. I'll just use this screen because I have the pen in my hand. So we have that stack heap diagram, our stack, which represents our code and the heap. Then we have that list with a bunch of pointers going to other elements. And before our revert, all we did is we changed the pointer to come down here instead. So it was still there. But with the reset, we change the pointer and we do this. So it's got, when we reset, it's gone. There's no getting back to it. Pictures are worth 1,000 words, right? When we actually see it erased from the picture, it's like, oh, that is very different than what we just did.
So
You cannot revert to reset.
So when I did head, or when I did the you did head, right? That's the
Yeah,
one
he's
you
the
put in.
one with the head.
So when I did that, it says head is now at whatever I typed in, which is what it was already at. And so when I did my one line, it's still there in my log.
Okay. So let's take it a couple steps further back. All those, let's go past all those reverts. Git. Oh, I need the git log one line. So we can see what it is. Let's go all the way back to here.
To the third commit or
To
second?
another commit. The very second one we did.
Okay.
So before we start doing all those reverts, it's like, okay, this is confusing. Let's just delete all the way back here and add the file. So we don't have so many extra things. So copy that. Git reset to that
And now I have to.
dash dash R. So head is now pointed at that. Git log. One line, so it fits on the screen. And notice that stuff is long gone. When we reverted, it was still on the list. And we had another commit afterwards. So obviously conversion control, you're probably going to want to do reverts.
Yes.
But when you're debating it, discussing it as a team and going back and forth, you're going to have reverts of reverts of reverts. And after you get finished and finally have it settled on what's going to happen, then you can undo all those reverts of reverts and clean it up a little. There is no undoing a reset.
Is a reset logged the way a revert is logged as a commit?
We only have 2 commits, and if we look at our message, git log, look at the full message, it's still the original message we put there. So our reset actually turns back the clock to that time. Be very careful with the reset. It's for cleaning things up, and a whole lot of people will just tell you to never use a reset at all. Like, just never do that. Just add more commits, it'll be fine. Add more reverts, it'll be fine.
Wouldn't be surprised if it were company policy to not do that.
Some companies probably is a policy. Let's add that file back in. Let's get back to 3 files like we were earlier. Any questions about reverts and resets? Probably going to do reverts all the time. I use resets to clean it up, but lots and lots of people will advise you to never use a reset. It's not going to hurt it. A git snapshot, we haven't really talked about what the commit is tracking. It doesn't keep a tracker. It doesn't keep a copy of our file. It keeps a snapshot of it and only keeps the differences. So whenever we make a commit, it looks at it, compares it to what it used to be, and only keeps those differences. So it's very, very small what's actually saved between the different versions. So if we go back 5 or 6 versions, it goes back through those small changes. So storage is not a problem on doing reverts and keeping all that extra stuff around. So a lot of people just say that. I'm going to add in again the more.txt. A text file to make sure we have at least 3 things to work with. Save, close the window, back here. Git add, git add dot. And that one happened on accident, but once again, we see how great the error messages are here. They all come with tips. Maybe you wanted to say this. Oh, you don't want the tips? Here's the command to stop getting the tips and the error messages. Very, very detailed, very thorough, very some of the nicest error messages anywhere. So we'll add that, and then we'll make the commit. And for our class here, we're pretty much never going to use that dash in parameter again. We're going to go in the text file and actually do stuff in the text file. And it is just one of the files when you say git init and initialize your repository. One of those files it clearly says text editor bin. So if you want to switch that to VS Code or Sublime or Notepad++ or brackets or whatever your favorite text editor is, text wrangling, or straight use Xcode or something, one of the really nice editors. Use PyCharm. It's a really nice text editor even for text files. Whatever your favorite text editor is, you can switch it to that. It's very obvious when you see it. What do we do here? Well, we made all those changes, so this is back to the 3rd commit. We made a whole bunch, but then we got rid of all of them. We deleted all of them. They're not even in RAM anymore. Let alone long-term, they're not in long-term storage or short-term storage. They're long gone. Our third commit is just added back a third file after doing all of or some reload and reset stuff. Obviously, we're on night 3 of the class. There's going to be more to see of this as we learn more about Git, because you can see that's kind of that's one of our primary tools for version control, and that's what we're studying. So we're going to be using our main version control tool a lot. And I'm putting these error messages in here to indicate this is a great place for notes as you're learning, right? You sit around and play around with stuff after class or on your own project. This is a wonderful spot for your class note because you can type big long messages in the body here. No issues to fix. No issues to worry about. We'll get to issue tracking soon. You can quit that file. Nothing fancy there. All stuff we've seen before. Git log one line. So now it looks like it did, what, 45 minutes ago? Half an hour ago? A while back, but those steps in the middle, that is the Git ops operation. That is a really good paying set of or subfield career choice in software development is to be the Git ops person. To just be the one on the team that manages the repository, that has those debates. You're looking through all the commits, everything on the team made, and you're running back and forth around the cubicles. So one thing, you're not stuck at a cubicle unless you just do it all through Teams or Slack or a chat message. It's a nice excuse to leave your desk and run back and forth and talk to all the different team members and be like, going back and forth there, what was going on here? Somebody down the hall was doing something similar but a little bit different, and making sure it's all organized. The Git ops person managing all those reverts and organizing what the rest of the team did. But we need to look at them a little bit better, don't we? So we have all that. What if we just wanted to go back and do stuff, but we didn't want to revert? It's like, there's something that probably could have happened on that another commit here, what I called another commit. Probably something else we could have done there. Like, maybe we could have wrote a hello world in Python there. So we want to go back and work on that branch, but we don't want to revert to it. We can check out the branch. I need to add some stuff to the list. Git check out, and let's go back to the first commit. Let's go all the way back to that README. Copy that, paste that. And an error message is going to pop up here. And I'm going to write some of these commands on the board, and then we'll talk about that message. It's not an error message. Sorry, I shouldn't call that an error message. A message pops up, and I'm going to write. So we saw git revert the commit hash git reset, and earlier log we could use the title. That would be okay. We cannot use the title here. We cannot revert and reset to the title. It has to be the hash. Git reset the commit hash, and then we want to add in the -- hard parameter. And at some point in the future, we'll talk about other parameters than hard. But hard's right, the one that's still there and the one that's completely deleted. Those are going to be our primary two, at least for starting with. And just added this new one in here. So this is undo but keep. And this is the delete. Do I have enough to do a second column? I only have one more. Is that true? Yeah, I guess it'll show up on the screen. This is the last one of the ones that are going on the board because everything after the break is about logs. Git check out, which we will keep again, like a bunch of this stuff, we're gonna keep coming back to it throughout the semester and extending it. And for now, let's do the commit hash. And while I wrote those on the board, it was probably time for y'all to read that message, right? Kind of clear what it is. We're in a detached head state. So with over in the stack heap diagram, we have our list. That element points at that element. Whoops. That doesn't look like an arrow. That element points over at this element, which points down at some element over here. And we filled up RAM kind of randomly with those pointers, and eventually there's a null pointer, which electrically is just a signal to drift to ground. Null pointers aren't always bad. You're probably always used to those error message, null pointer exception.
Right.
But in the case of a linked list, a null pointer is how we know we're finished. When we hit the null pointer, we're at the end of the list. And electronically, it literally does just that. The remaining electricity goes to ground. So we have all that stuff over here, but we want to, and change the color here. This last commit here is going to be the head of the head. But we want to come back and do something over here. So what we did is we made a copy of this element. So somewhere else in RAM, we have a copy of that head. We know what was, and then that it's a special kind of copy, so we know what was pointing at it and what it was pointing at in case we want to replace the original with that copy. But the thing we're working on is completely pulled away from our head. We don't have access to it from the head of our linked list. And you can see, we haven't talked about branches yet, but we have to create a new branch in order to do that. If we try out our changes and cancel them out, get rid of all of our changes, just run git switch dash.
So use case, you committed something previously, maybe something is wrong with it, but most is right, and it's in between. So you want to get the right elements out of and deal with. So you're pulling that, if it could potentially pull it around and without dealing with this stuff in the middle.
Yes, because remember, it shouldn't be a backup system. Every commit should have a specific purpose.
Right. So you don't want to revert all the way down to this.
You want to fix it at the commit where it should have been fixed to begin with.
Right.
Like here, maybe we should have had a hello world file. But we didn't have any code in that initial commit. We should add something. So let's create a sublime hello world, hello.py, and import emoji. Did y'all see in the grade book that I have emojis in the grade book now? Every one of y'all got a thumbs up, I think, unless you haven't come in the week one homework. Yeah. But I have emojis in the grade book. I was so excited. Even people that already had it graded, I went back and added emojis in there. So import emoji and print.
And I did get that to work.
Leaving hand. Yeah, I was doing a waving hand one. Let's do a hello, not hello world. Save that. Close that out. We can test it. Have the Python interpreter run hello.py. Oh, no, still didn't work. Got to go in and edit it. Hello.py. We don't want to print it. We want to print emoji library.emojize function on all of that stuff. Put up another there. Getting ready to say something and forgot what I was getting ready to say here. I'll test it down here. Open this. Oh, yeah, I remember what I was going to say. If you want to, a lot of people don't see this in the Python course. you can put your shebang going to your Python interpreter. So on my computer, it would be the C drive, the slash, users, rank, app data, local programs, Python 3-11. So has everybody seen the shebang before in Bash script? It doesn't have to point to your Bash interpreter. You can point to your Python interpreter or run your Python code. And what that bypass is doing is that, I'll skip all that. Then when we go to run it, we would say, use the Python interpreter to run that file. But if you put that shebang in there, the comment symbol and then the exclamation mark, so like bang, where the name comes from, it tells what interpreter it came with. So PowerShell scripts, any interpreted language that shebang goes into. Most people only see them in Bash scripts, but you can put your shebang to point your shebang to any interpreter. If you're in a Bash shell, you can point to your PowerShell interpreter. You can point to your, we can point to any one of our interpreters. And a lot of people never see that in the Python course discussion. It's like, okay, that works. So we can say git, add that file, git commit. I'm just going to do a message sheet. I'm just going to do the dash in here. Adding a hello. And notice that we are still in that detached head state. So we're disconnected from the rest of our linked list. We can't go to the beginning of the linked list and walk through our elements and find this one. It's sort of a secondary list. We see all those changes. Git log one line. And notice we only had those changes. We just went back and made a completely different version of our repository right from the beginning. And then that detached head message kind of indicates that we have had no impact whatsoever on our existing code. So for the use case, like you were saying, if something should have been fixed five commits, 5 sections ago, it's like, okay, this typo got overlooked. Somebody got to debug this function and it got committed, and we've done a whole lot since then, and it's a minor function we never needed. We don't want to fix it now and do a commit just for that specific thing. We can go back to where it should have been fixed to begin with and fix it there. To control our versions, not just edit our versions, not just edit a new version. We can get back to any of them. That's the idea of a version control system. So, okay, no need to do that. So git switch, and if we wanted to keep them, we would add a branch. We would just create a new branch. But for now, to not keep them, it's like, we'll just add that in. We'll just fix it later. And when we go back and make those changes, it seems like it's not significant enough. So just a git switch dash. You're leaving one commit behind. So we are abandoning this. We're deleting it. We didn't decided not to keep that. We will see how to keep it when we get to branches. And we switch back to the main branch. So if I go back to git log one line, you'll see that added a hello commit is gone. It no longer exists. Sorry. And we're back to our earlier version. See where version control is coming from now? It's not the same as adding just the little addendum at the end of the file name. Version 1, version 1 fixed, version 1 fixed part 2, all of that mess. That's we can actually go back to what it was earlier without deleting what it is now, and have full and total control over our version. Any questions about that stuff? Oh, I guess I can hit ls. You see that Python file is gone. It no longer exists. Just like when we were in the detached head state, we were only looking at that. And if we open the file explorer, we only see the current version. Message about head. Note the commit name and notice that that commit is gone and the edited files are gone. Okay, so that's what I have for the notes for before the break. Any questions? Or 10 minutes sound good? Good. I'll give it a couple seconds so people on the Zoom call have time to reach the mute button. Okay, I think there's no comment. No, silence means no questions, so let's take 10 minutes real quick. My laptop says 7:16 and we'll get back to it at 7:26. I'll see y'all in just a moment.